Hello and welcome to this technical training segment. I'm Jeremy Cooper with Sabre Consulting. Today we're going to look at the IPv6 portion of the CCNP TSHOOT exam. For those of you who are not particularly familiar, the CCNP Route and Switch certification by Cisco is comprised of 3 exams: Route, Switch, and TSHOOT. The route exam is all about routing protocols, specifically the IGPs as well as BGP. And with IGPs, I mean EIGRP, OSPF, and possibly some RIP. I know they took it out at one point, but they may have reintroduced it. It also deals with things like Layer 3 path control, which would be like policy-based routing, as well as modifying metrics and distribute lists to cause traffic to flow differently than what it would in normal situations. The switch exam is all about layer 2, so we're talking about VLANs, trunking, we're talking about layer 2 security like dynamic ARP inspection, IP source guard, spanning tree, both classic and rapid, as well as multiple spanning tree, as well as a lot of the different security mechanisms like loop guard, root guard. It also deals with redundancy protocols such as HSRP, VRRP, GLBP. And once you get those 2 really difficult exams out of the way, you get to the TSHOOT exam, and it's a huge amount of fun. You are basically given a topology, and Cisco publishes the topology. In fact, this GNS3 mockup is my own little rendition of the exact topology of the exam. And what you do is you're given trouble tickets in which, okay, PC number, the PC at the edge of the network is unable to ping the FTP server all the way out on the internet, and you have to go through the different devices and do various show and verification commands until you identify the fault, and then you answer questions relating to them, the fault exists on router 3. It has to do with this technology, and this is the syntax you would use to fix it. Well, additionally, you also have an IPv6 topology, and it's basically just IPv6 overlaid on the main routing topology. And we are going to take and configure IPv6 per the exam topology in this segment. So what I've done is I have gone in and I have configured the IPv6 addresses on the various interfaces. And we're going to then set up OSPF version 3, which is IPv6, between these 4 routers, 1 through 4. And also we'll be doing a GRE tunnel between routers 3 and 4. And then from R4 to distribution switch 1 and DSW2, we will set up RIP-NG, or next generation. And then finally, we will redistribute the protocols between each other so that you have full IP reachability from DSW2 all the way to that FA001 interface on R1. So these are the tasks that we're going to perform. Oh, and sorry, before I jump into that, I want to say something else. The TSHOOT exam, because you're not answering all these nuanced questions about, like adjacency, the adjacency process between OSPF or the different type of path vector attributes of BGP. It is considered to be an exam that is relatively easy to study and prepare for, and so a lot of people will use it to renew their certifications. For example, I've held a CCNP route and switch since early 2013, so on 2 separate occasions since that point I have taken the TSHOOT exam just simply to renew my Cisco certifications. So there is a lot of value to doing this exam just as a quick and easy way to renew your certs if you do not have the time to allocate to say taking the Arch exam, for example, to become a CCDP or design professional, or whether it's security or voice or whatever. So we're going to move the GNS3 topology over to the left-hand side, and we are now in SuperPuTTY, and I have created reverse telnet sessions into each one of these routers. We have pre-staged the IPv6 addresses between each interface. And up here in the commands, we're going to do a show IPv6 interface brief, and we can look and see real quick. Feel free to pause the video to just allow yourself to look really quick and verify that all the correct interfaces are up, and the IP addresses are set correctly. So we'll start with R2. We're going to set up OSPF area 0 between R2 and R3. So first thing we do after going into configure terminal is you have to type in IPv6 unicast routing. And now we're going to turn on the OSPF version 3 process and set a router ID in. Because we don't have any IPv6 addresses configured on this box, we're going to have to manually set the router ID, and I'm going to use 111122223333 and so forth as the router ID. So it's IPv6 router OSPF process ID 6, enter, and really helps to OSPF 6 router ID 2.2.2. So router ID is configured. Now we'll go into interface FA1/0. Interface FA1/0, and the command. This is a little different from how you were traditionally taught IPv4 or OSPF v2, in that you can only advertise OSPF via interface commands. You don't do network statements, although you can also do that in OSPF v2, but you can also do the more traditional network statements. So the command is IPv6 OSPF, and it's process ID and then the area. Don't know how that happened. Okay, so let's go over to R3, configure terminal, IPv6 unicast routing, IPv6 router OSPF 6 router ID 3.3.3 exit interface FA1/0 IPv6 OSPF process ID 6 area 0. So if we did everything correct, we should have an OSPF adjacency popping up really fast. Show IPv6 OSPF neighbor. All right, and we are currently in the two-way state, so we know then that the process, the neighbor adjacency is negotiating. So if you're like me and you spend 95 to 98% of your time, whether it's in study or consulting and running networks, if you spend 95% of your time in IPv4, you really have to stop and be very conscious about typing IPv6 instead of just IP. So while this process is negotiating, there we go, we will go ahead and jump back to R2, and we're going to configure the interfaces to make this link hot. Interface FA0/0 IPv6 OSPF process ID 6 area, in this case 12. Go to R1. It's the first time we've touched this router, so we have to do IPv6 unicast routing, and then I'll hit the up arrow and Control W to delete the previous command so I don't have to type IPv6 again. Router OSPF process ID 6 router ID 1.1.1 exit interface FA0/0. Sorry. IPv6 OSPF 6 area 12. And always a good habit, save your config frequently. Show IPv6 OSPF neighbor. And all right, we're in the process. So in just a moment, we should have reachability. If we go over to R3, as soon as this is done, we should be able to see this. We should be able to ping 2026::12:1. Show IPv6 route. I'm going to maximize this screen right now so that the output is a little bit more helpful. Although the actual command is route. There we go. Okay, so we have learned about an inter-area route. So I bet if we ping 2026::12:2 and :1. Wonderful. We have IP reachability. All right. And Super Putty is an awesome tool, but every so often it goes a little bonkers and it won't automatically resize with the window arrow keys like most Windows will. So at this point we have IP reachability between our first 3 routers. Now we're going to set up that pesky little GRE tunnel between R3 and R4. And don't let it intimidate you, it's not that bad. So we're on R3. We already have our, let's do a show Ipv6 brief again. So we already have our IPv6 set up. Let's go ahead and configure an IPv4 address on those same overlaying interfaces. And actually, I apologize. That's not actually how you would do it in the exam environment, or rather, that's not how the exam environment would be set, because this isn't how you do a GRE tunnel in which you run IPv6 on top of IPv4. So we're going to go back into this interface, fa0/1, and do a no IPv6 address. Instead, it's just going to be the classic IP address 10.1.1.9 255.255.255.255.2. Let's do the same on R4. No IPv6 address. IP address 10.0.0.10 10.1.1.10. There's my mistake. Ping 10.1.1.9. There we go. We'll start on R4. The first step is we define our tunnel interface, and you do it in the same way you would a loopback. You just type interface tunnel, and I'll give it tunnel 0. So next we're going to give it its IPv6 address, IPv6 address 2026:34:2/122. Now we're going to do IP destination, and I am totally winging this. I haven't done this in several months. Maybe it's tunnel. That's it. Tunnel destination. That's going to be the IPv4 address 10.1.1.9, and tunnel source is going to be our local interface, which is interface. Oh, and it just wants to go straight to fast Ethernet 0/1. Wonderful. Okay, let's go back to R3. Configure terminal interface tunnel 0 IP address. IPv6 address 2026:34:1. I'm on R3. What did I do on R4? Show run. Show IPv6 int brief. I may have. I did. Okay, I did it correct. Very good. R3. 2, and this is 1/122. Tunnel destination 10.1.1.10. Tunnel source FA0/1. Line protocol on interface tunnel 0 change state to up. It appears therefore that we should be able to ping. Okay, we can ping across that tunnel. At this point, setting up Ospf V3 over the tunnel is as simple as doing it on any other interface. It's just, instead of going to the physical interface, we go to the logical interface, tunnel 0, interface tunnel 0, IPv6 Ospf 6 area 34. Let's do the same on R4. Configure terminal interface tunnel 0, IPv6 Ospf process 6 area 34. Oh, IPv6 unicast routing is not enabled. IPv6 unicast routing, and we'll do IPv6 router Ospf 6 router ID. Now, real quick question. As soon as I enabled the router Ospf 6 process, why didn't we get that console message saying it couldn't pick a router ID? Pause and think about it for one moment. The reason is we have already defined an IPv4 address on this router, whereas we had not in the previous, and that would be 10.1.1.10. I'm going to go ahead and specify router ID 4.4.4. Show Ipv6 OSPF neighbor. Ooh. Show Ipv6 protocols. Show run interface tunnel 0. Ipv6. Oh, that's because we got barked at up here because IP unicast routing wasn't configured yet. Configure terminal interface tunnel 0, Ipv6 OSPF process ID 6 area 34. Up arrow. All right, there we go. So out of curiosity, let's do Ipv6 OSPF neighbor, and because the adjacency wasn't yet up, it was made with the router ID of 4.4.4. I was kind of hoping that because I did things slightly out of order, it would come up with a router ID of 10.1.1.10 because I wanted to show what you had to do in order to change the router ID, and that is on the local router you have to clear IP OSPF processes. So at this point, we have set up OSPF version 3 on routers 1 through 4. We have completed task 2, which is configure IP tunneling between routers 3 and 4. And now it's time to jump over to RipNG. And let's go over to DSW2. Now, why you would ever use RipNG in a production network, maybe if you were trying to support some type of legacy router at the edge of your network that only ran RipNG, but that's definitely a corner case, but Cisco wants you to know about it, so we're going to do it. And RipNG is slightly different just in the sense that there is no turning on the RipNG process globally like you do in OSPF or EIGRP. You know, in terms of setting a router ID, you just go straight into the interface and you enable it there. So configure terminal Ipv6 unicast routing, interface FA0/1, Ipv6 rip, and then we give it a name, and it's rip zone in the exam topology. Oh, and enable. Let's go to DSW1. We're going to do the exact same thing. Configure terminal Ipv6 unicast routing, interface FA0/1, Ipv6 rip score zone. Make sure you do those exactly the same. And then we have to do that on FA00 as well. Go to R4. We do not have to enable IP unicast routing, interface FA0/0, Ipv6 rip zone enable. So we should see on DSW2 show Ipv6 route. Yes, we have a RIP learned network 2026::2. Excellent. Ping 2026::2:1. Yes, so we just pinged from DSW2 all the way to the FA00 interface on R4. So we have just configured RipNG between these routers. Now, the final step. We want to set up IP reachability from DSW2 all the way up to FA00 on R1. This is performed on R4. This is our autonomous system boundary router. This is the router that it has its feet into universes, and now we want to bridge that gap. So we'll start off in configure terminal in Ipv6 router OSPF 6 redistribute rip-zone, and you don't have to do the subnets command with IPv6. It knows it instinctively. So now we're going to remember how to do this within RIP, and I may have made a mistake when I said there is no process for RIP because there clearly is, because you have to redistribute from here. Redistribute OSPF, and yeah, it would be OSPF 6. And this is the key. You have to include the argument include-connected, or it's not going to get these connected interfaces. And that's pretty critical since you don't have loopbacks or VLANs and other routed networks in this topology. So from DSW2, show IPv6 route, and either we still haven't updated or I have done something wrong. Show IPv6 route. Let's see if, yep. So I have half of it correct, because you see we have an OSPF E2 that is an external type 2 route, which is the default because I didn't specify whether I wanted it type 1 or type 2, so it used the default. So I have redistribution halfway working. Now, of course, it's not working at all, and I will demonstrate that. Ping 2026::3:2, because DSW2 does not have a route to get back to the source address of R1. Show run. So, well, section router. So we have not successfully redistributed OSPF 6 into RIP. That's where the mistake is. IPv6 router RIP zone. And that is the correct. Interesting. Look at the mistake I made there. And I wonder, you'll note the fact that I didn't capitalize RIP zone here in DSW1. Let's see if that's, I would reasonably argue that's the mistake I made. Let's see what I did on DSW2. Show run fa0/1. Okay, so the only place where the word RIP is fully capitalized is here. Show run int fa0/0. However, we do have IP reachability to DSW2. So that apparently is not the problem. The problem most likely, though, is right here. Because well, I don't know. Let's just clean this up. So in every other location, no, that's not true. There we had all RIP. All right, configure terminal. No IPv6 router RIP sorry, zone. IPv6 router RIP zone. Redistribute OSPF 6 include connected. Oh, I just did that on DSW2. No IPv6 router RIP zone. Let's get back to R2. Show run section router. Okay. No IPv6 router RIP zone. IPv6 router RIP zone. Redistribute OSPF 6 include connected. Ooh. Show run when I said no IPv6 on DSW2, that removed RIP from that interface. FA0/1 IPv6 router RIP zone. Didn't do enable. I guess because it's already been enabled. Show IPv6 route. Slow down, Jeremy. DSW1. Show run 0/1. Okay. Still haven't learned anything. All right, I already have that. Show run FA0/1. What happened there? We just added RIP and it didn't show up. IPv6 route RIP. IPv6 RIP zone. Now I've got enable. I bet I was typing router RIP. Sorry about that. Show IPv6 route. I have now learned, is this 202.6.2? Okay, that's this one. And I've learned :3.4. Hey. I learned a route. I learned a route from R4, but it didn't advertise the rest of the routes. Ping 2026::34:2. Control-Shift-6. Let's look at R4. Show IPv6 route. R4 has lost all of its RIP routes. Show run int FA0/0. R4 show run int FA0/0. Okay, that would be why. When I renamed those processes, IPv6 RIP zone enable. Now remember, RIP waits 30 seconds between advertisements. So when you make changes within the RIP routing protocol, those changes are not as instantaneous as they are within the other IGPs. There's 34. Okay, well now from DSW2 I can hit this interface on R4, but I can't here show IPv6 route. Yeah, it doesn't see any E2s. So let's go back to, well, that was R4. That wasn't very helpful. Show IPv6 route, because it's not going to show any E2s. Okay, but R1 doesn't show any E2s, so I'm willing to that's interesting. I lost okay, when we said no router RIP, wow. I'm really impressed. It got rid of all, I guess you'd call them artifacts. When I said no IPv6 router RIP zone with the capital RIP, it removed every reference That's actually kind of a good thing. It just caught me a little off guard. So we'll go back into IPv6 router OSPF6, OSPF6, redistribute RIP zone. Now we're back to our waiting game. Well, say that. We now have an E2. This is from R1, so it's seeing this network here. So that is a very good sign. One thing I wish Cisco had was the pipe refresh argument, and maybe newer iOSs do, to where you can just cause the command to refresh periodically, and it is not. I feel like we still have something done incorrectly, because we're only learning one RIP network or two RIP networks depending upon where you stand in the hierarchy. So let's look at this again. Include connected. So what's happening is RIP. Oh. RIP had, trying to remember if RIP is like EIGRP in that you have to have a default metric, but I don't remember seeing that stipulation when I was reviewing this. Router RIP zone. See what our commands are. Distance, maximum paths. Redistribute OSPF6. Include connected. Let's do a metric of 2. In other words, remember RIP is a hop count, so metrics go from 1 to 15, and it's very possible that RIP does not include a default. And that was it. That was it. Okay, so now ping 2026::12:1, and yes, we have full IP reachability from DS2 all the way to R1. So a couple of mistakes we made. One, in fact, virtually all of our mistakes were with regard to route redistribution. So, one, when you're setting up the process name for RIP, be very case specific. Be consistent with your case across all devices. 2, when you realize you made a case sensitive issue, or maybe you typoed something, and you do a no IPv6 router RIP, in this case RIP zone, remember that removes every reference to RIP zone on that router, so you've got to go back and clean everything back up. Additionally, when you do your redistribute within RIP, you do include connected, but you also, like EIGRP, like the other distance vector routing protocol, or as Cisco likes to say, a hybrid, but like the other distance vector protocol, you have to specify a default metric. Otherwise, it gets black holed. So, that is it. This is definitely not, I wouldn't say this is 100% comprehensive of anything that could get thrown at you on the TSHOOT exam with reference to IPv6, but this covers a lot of the basics and is a great starting point. So, I hope this video has been helpful. Thank you so much for viewing, and have a great day.